Hello, this is Chantel, and I'm going to be talking today about section 4.1 from the XYZ textbook, and it's about inverse functions. So the first thing we need to talk about is that an inverse function is a reflection over the line y equals x. So I'm going to spend a moment on that, because if this is something that doesn't make sense to you, you need to stop, go to the book, go watch a different video. Make sure this makes sense to you, because everything we do is based on this concept. So the line y equals x is the red line that's right there, and it's just a straight line, and it goes right through the origin. It's a line with a slope of 1 with a y-intercept of 0. So every time there's an x, say of 1, the y is also 1. Okay, so when it's 2, it's also 2, and everything in between. Okay, so if that doesn't make sense, please go stop for a moment, look at the book, and spend some time trying to figure out what that means. So a reflection over that line is going to be something like, let's just say we have a graph that looks like this. Then the reflection over it is going to be over here. And for every x, y coordinate, the x and y will be switched so that the x in this point over here equals the y in this point over here. This is not a great drawing, but that's the idea. So I'm going to show you some examples of that. So the first one I have is just a straight line, and this is the line 3x minus 4. And so there's nothing complicated about that. It's just a straight line. The y equals x line is here. And then if you want to see the inverse, I've got that, the inverse of that line, which we're going to talk about how to find the inverse soon. But I just wanted to show it to you. And as you can see, every time there is a point, say 1.5, 0.5 right here, then there's going to be a point up here just exactly with the opposite coordinates. That one is 0.5 and 1.5 right there. Okay, so I'll get rid of that one and I'll show you a different example. Another example is the line y equals the square root of x. So y equals square root of x is partly on the left or above the line and partly to the right or below the line, however you look at that. And then when you find the inverse of that, you see that it is exactly the opposite. So every time you have a point on the regular line, you have the exact opposite point on the inverse of it. Okay, and I just also wanted to point out that the inverse here is x squared. This is square root of x. This one is x squared. Okay, so it really goes on over here, and we're going to talk about limiting domains later in the lecture. So the last one I want to show you is the line y equals cube root of x. So the green line is the cube root of x function. And when you take the inverse of it, the inverse of cube root of x is x cubed. And it looks exactly flipped over as if the line y equals x is a mirror. Okay, so hopefully that gives you a little bit of an introduction to what inverse actually means. Right. So here's a couple pieces of information for you. This first one, we write inverse f of x. So the inverse of f of x we write as f superscript. So that's f to the negative 1 of x. Okay, so this is how we write inverse right here. It does not mean 1 over f of x. Definitely does not mean that. Okay, so no, that is not what inverse means when it comes to functions. So try to remember that is definitely not it. So inverse, we're going to talk about how to find it in just a moment. So a simple way to create an inverse, as I spoke about up here in the graph, is that every time you have an x in a coordinate, you turn it into y. And every time you have a y, you turn it into x. So the x becomes the y, and the y becomes the x. We're not going to write it like that, but that's basically the idea behind what we're doing. So this is the x, and this is the y, but we just put the numbers in from the x, y, and you end up with exactly the opposite as we did up here, say, for 1 and about 0.5, and then the other point on the inverse line becomes 0.5 and 1. Right? So I'm going to continue on and give you some examples. Okay, I'm going to go through the steps here of finding the inverse of a function. And you just need to do this every time, and you'll see that it's really not all that hard as long as you know how to rearrange an equation. So wait until I'm done talking and then pause the video and you can write these steps down. So first you want to write the expression for f of x. So just write it out. And then you want to replace f of x with a y. So just rewrite it and put y when you see the f of x. Then the next step, step 3, is the key step. You want to switch the x and the y in the expression. Anytime you see an x, you replace it with a y. Anytime you see a y, you replace it with an x. Then step 4 is you want to solve for y. And then you rewrite it, replacing the y with f to the minus 1, which means inverse function. We want to replace it with the inverse function of x symbolism. Okay, so let's try that. So you can pause there and write that down if you'd like, and then come back and let's work this problem. Okay, so like I said, we're going to replace the g of x with y. So y equals 4/3 x. And then the next step, step 3, is to switch the x and y in the expression. So we're going to make this x, and we're going to make this y. So I just switched the x and I switched the y to be opposite. All right, now in order for it to be in the form of a function-based function in terms of x, so we have to put it as y equals. So now we're going to have to rearrange so that we say y equals. So we're going to multiply both sides by 3/4. So 3/4 on both sides. And the 4/3 cancels out or divides out, and we get, and I'm just going to write it in the other order with y on the left. So we get y equals 3/4 x, and that is our inverse equation. So I want to show you what that looks like. So there's our y equals x line. This is 4/3 x, and just take a moment and try to picture what the inverse is going to look like. And the inverse is y equals 3/4 x. So for every y, we replace it with the x, and every x, we replace it with a y. Okay? All right, so we're going to go back and do a couple more examples. So the next example is number 40. Okay, so for number 40, the first thing we want to do, as we did before, the steps aren't up there, but hopefully they're in your notes and you can take a look. The first thing we do is replace f of x with y and rewrite it. And the next step, number 3, is to switch the x and the y. So we get x equals negative y cubed plus 4. Now we have to rearrange to solve for y. So I'm going to take the y to the other side. I'm going to add it to both sides, and I get y cubed plus x equals 4. So I just added y cubed to both sides. And I'm going to subtract the x now, and I get y cubed equals 4 minus x. And now I have to take the cube root of both sides to get rid of the cube. Make sure you do the cube root, or else it won't get rid of it. And I get y equals the cube root of 4 minus x. Okay, so that is the inverse function. So these two are inverse functions, and we're going to rewrite this as f, and I think I forgot to do that on the last one, f minus 1, so inverse function of x equals the cube root of 4 minus x. Okay, so that is number 40. So we have the function and we have the inverse function. And let's take a look and see what they look like. So there is our y equals x line. Here is negative x cubed plus 4. And I'm going to take a moment here to fix this so we can see the whole thing. Okay, so I just had to zoom out just a little bit so we could see the whole graph, or at least the important part of it. And that is the negative x cubed plus 4. And as you can see, it looks like x cubed. It does this bit. That's what the x cubed looks like, except it's flipped. So x cubed would normally be over here, but now it's flipped because it's negative x cubed. And the plus 4 caused it to shift up for us. Going back to transformations a little bit just to talk about that. And now the inverse of this is going to look like that. So as you can see, if you folded it on the y equals x line, they would land right on top of each other. All right, so going back to our discussion here. Okay, next I'm going to talk about, is it really an inverse function? So sometimes you're given two functions and you're asked if they are truly inverses of one another. There is a skill that we have not learned yet. It was in section 2.7. It was on a little over a page of that section. We didn't do the rest of it because it wasn't necessary, but this section is necessary, so I'm going to teach it to you now. It's called composition of functions. And we use these composition of functions to find out if two functions are inverses of each other. So you might want to stop the video now and go to page 187 of your book so you have it in front of you. All right, so the definition of a composition of a function, two functions, f and g, is denoted by this symbol right here, where you've got f and a little circle and g, and we say that of. Okay, so just like we say f of 1, and we're going to plug 1 into the function f, now we're going to have a function of a function. So now we have f of g of x right here, f of g of x. And so I like to rewrite it like this because I think it's more usable in the way that we're used to using it. So just like we had f of 1, now we're going to have f of g of x. So instead of putting 1 into the function, we're going to put the function g of x into the other function f. Okay? And we'll talk a little bit about domain, but not much because that doesn't have too much to do with what we are doing here. All right, so I'm going to go on and show you an example of how to do this. Okay, next we're going to talk about how to do this with example 4. So let's look at this example. We've got f of s equals s squared plus 1 and g of s equals negative 2s. And they're asking us in A to find an expression for f of g of s and to give the domain. We're not going to do giving the domain here. It's not important for finding if two things are inverse, what this is all leading to. So we're not going to worry about that today. So we're going to find an expression for f of g of s. So f of g, looks like fog, I know, of s is the same thing, and I like to rewrite it as f of g of s, like that. Okay, so the first thing we're going to do is say that f of s and replace the g of s with a negative 2s. So we've got, but what I'm going to do here is I'm going to put a box in here in red. We're going to replace that box each time with what g of s is. And I'm going to do that for a little while until you get used to doing this. All right, so f of s is s squared plus 1. So we're working with f of s right now, and that is s squared plus 1. But instead of an s, now we're going to replace it with whatever g of s is, and I'm going to put a box here. Okay? So that is s squared plus 1, but now it's not s anymore, it's whatever g of s is. G of s, if we come back up here, g of s is negative 2s. So I'm going to put negative 2s inside the box. Okay, and I'm going to use parentheses so I don't forget to square everything in there. All right, then what I'm going to do is I'm going to go ahead and just work this out and find what f of g of s is. So negative 2s squared is going to be 4s squared, and then the plus 1. So that's what you get when you take f of g of s. All right, let's try b is the opposite. It's going to be g of f of s. And again, I think it's a little hard to read that or to follow it, so I'm going to rewrite it as g of f of s. All right, so the thing that we're finding in the equation for g, the function of g, is f of s, and I'm going to put a box there so we can maybe follow that a little bit better. So g is negative 2s, but instead of having an s, we're going to rewrite it as negative 2 and put a box where the s goes. Okay. All right, so the s here is f of s. So just like we put g of s inside the box here, we're going to put f of s inside the box here. Okay, so f of s was s squared plus 1. S squared plus 1. We want to make sure and use parentheses. All right, we're going to continue on with that, and all we have to do now is just distribute the negative 2. So we get negative 2s squared minus 2. Negative 2s squared minus 2. Okay? So that's how you find f of g of something, and you find g of f of something. So now we're going to do it with numbers. All right, I'm going to do this 2 different ways. We've got f, because sometimes you don't work this out first. They just give you a number. So I'm going to show you how to do it without having worked it out first, and I'm going to show you how to do it having worked it out first. F of g of negative 1. So now before we did it with an s, well, f of g of s, as we did right up here, this one, is 4s to the 2 plus 1. So we want to replace the s right here, this s, with this. And I used the top one because it was f of g. So take a moment to look at that. We did f of g of s. Now we're finding f of g of negative 1. So I'm going to replace the s with negative 1, and I get 4 negative 1 squared plus 1. Okay, so I get negative 1 squared is just 1. I get 4 plus 1, which is 5. Okay, so we get 5. Right, there's another way to do this, and that is to work it out from the beginning, like I said, as if you hadn't done a, because you're not always going to do that first. So what we're going to do is f of g of negative 1 is f of g of negative 1. So what we want to do first is we want to find g of negative 1 and see what that is. Okay? So first we're going to find g of negative 1. So you're going to use g above. You get negative 2s. So we do negative 2 and put negative 1 in for s. And we get 2. Okay, so now g of negative 1 is 2. And the 2 is what is going to replace the g of negative 1. The function g of negative 1. Okay, so give myself a little more space here. All right, so now we've got f of what? Well, g of negative 1. So g of negative 1 is just the 2 that we just found. So we put 2 in there. All right, so f of 2 then. Now we're going to find f up here is s squared plus 1. So s squared plus 1. Now we want to put the 2 in where we have an s, anytime we have an s. So we're going to replace that with a 2, and we get 2 squared plus 1, which is 4 plus 1, which is 5. So either way that we did it, we got a 5. Okay, I'm going to do the other one both ways as well. All right, so the other one is they want us to find g of f of negative 1. So g of f of negative 1 is the same thing as saying, well, first let's do it the first way. So g of f of s up above, we got 2s squared minus 2. So negative 2s squared minus 2. So anytime we have an s, we're going to replace it with the minus 1. All right, so we're going to get negative 2, negative 1 for the s squared minus 2. And we're going to get negative 2 times 1 minus 2, which is negative 4. Okay, so that is the first way, as if you have already done the g of f of s, and then you can just plug it in. All right, the other way, remember, is to say g of f of -1. Well, we have to find the f of -1 first, this part right here. Okay, so we're going to do that first. So we need to go and find what our f was, if we remember what f was. F of s is s squared plus 1. So s squared plus 1. So now the s is going to be the -1. Okay, so the -1 here is going to go in for the s, -1 squared plus 1. And that is, -1 squared is 2, is 1, sorry, squared, plus 1 is 2. Getting ahead of myself there. So now the 2 is going to go in for, we get g of something. Okay, so g of f of -1. That was this one right here. Well, f of -1 is 2. So we're going to put 2 in here, g of 2. So now we need to know what was g. Well, g is up above, and g was -2s. So we get -2s equals, and we're going to replace the s with the 2. So we get -2 times 2, which is -4. So either way we did it, we got -4 or -4, whichever way. Okay? So now I want you to give that a try. I know these are really confusing and very challenging, but I'd like you to try. Check it out 4. So this is in the book in section 2.7, but this is f of s equals s squared minus 2, and g of s equals 3s. And you need to find f of g of -1 and g of f of -1. All right. Okay, so here's the answers you should have gotten, and I'm not going to go through all of this. You can pause it and take a look if you didn't get it right. The one thing that I find very confusing is that when you find f of -1, you get -1. So you end up plugging -1 back in for f of -1, which makes it just a little bit weird. And I wish they'd chosen one that didn't work out for, but that's the way it worked. So anyway, you should get 7 and -3. Okay, so to figure out if two functions are inverses, we use the composition both ways. And if you get x out both times, they're inverses. So this is how you find if two things are inverses of one another. So let me say that again. If f of g of x is x, and g of f of x is x, then they are inverse functions. Pause the video, write that down, put a big box and a star around it. Okay, so just to talk about this, just think about if you take the inverse of an inverse, you should always get itself back out. And that's all we're doing right here. We're taking the inverse of the inverse. Okay, so let's just do a problem here and we can look at how this works. So f of g of x is what we're going to try, and we're going to see if we get x out, and then we have to do it the other way. And if we get x out, then they are inverses of one another. So we're going to take f of g of x, which is -1/8 x. Okay. Now we're going to take f of x is -8 times x. And this time for x, we're putting in -1/8 x. Okay, so be careful. Take this a little bit at a time. Use colors, whatever you need to do to keep track of what you're doing. And if you take -8 times -1/8, the negatives cancel, the 8s divide out, and you get x. Yay, that's what we were looking for. All right, so now we're going to try it the other way, and you may already see that that's going to work. So g of f of x, g of f of x is -8x. And g of x is -1/8, and instead of x, which would normally go right here, we're going to place it with 8x, -8x. Okay, so that's our f of x. We're taking g of f of x. All right, so once again, the negatives, the 8s cancel out, and we get x. So this means, yes, they are definitely inverses of one another. Okay, so going on to number 16, we're going to do the same thing. So we've got f of x is x cubed minus 4 and g of x equals cube root of x plus 4. And you may start to get good at being able to see that they are inverses of each other, but to prove it, if you want to prove it, you're going to have to say f of g of x and g of f of x and show that they both get x. So f of x is just x cubed minus 4, and g of x is cube root of x plus 4. So which one are we going to put where? We're going to replace the g of x here. When they get long like this, they get a little bit confusing. We're going to replace the g of x with what g of x equals. So I've got f of cube root of x plus 4. Okay, so we're going to take f of cube root of x plus 4. So that means we're going to put cube root of x plus 4 in every time we see an x. All right, so now f of x is x cubed, so cube root of x plus 4 cubed minus 4. So that's f of x. All right, well, as you can see, the cube roots are going to make each other go away. They're inverses of each other, and I get x plus 4 out of that. And then minus 4 is just going to give me x. All right, and then I get f of g of f of x is, so we're going to replace what's inside here, f of x, with what f of x equals, x cubed minus 4. So we're going to take g of x cubed minus 4. Okay, so now g of x is cube root of x plus 4. Well, every time I see an x, I'm going to put x cubed minus 4 plus 4. Okay, so the first thing we see is that if we just take away this parenthesis here, which is not necessary, there's nothing outside of it, and we can just remove it right here, then we can see that minus 4 and plus 4 go away. So I get cube root of x cubed, which is just x. So this is confusing and sometimes a little hard to follow even in your own head when nobody's talking to you. So it just takes some practice. So I'm going to have you practice this with check it out too. So what you need to do is find the inverse. So first I want you to find the inverse and check that it is the inverse. So in the Edpuzzle, you're only going to be able to find the inverse and tell me what it is. So please do check that it's an inverse. Practice checking with f of g of x and g of f of x and see that you get x both times before you answer the question, because then you'll know that you were right. Okay? So give that a try. Okay, so here's your answer. You should have gotten the inverse function of x is x plus 5 over 4. So I'll put a box around that in red here because that's your answer that you should have reported on the Edpuzzle. So you should call this, I called this g of x for the check because it's a little confusing with all the f's and then the minus 1s. So I just called it g of x and I wrote it up here. So this is the x plus 5 over 4 is right up here at the top. And then you just go through the f of g of x and g of f of x, and both times you get an x. Pause the video here if you weren't able to check it and just make sure you're following along. Okay, so next we're going to be talking about inverse functions being one-to-one. So this is one of those concepts that seems simple, but in practice is a little more complicated than you might think. So let me talk, then pause the video and write this down, and then we'll continue on. So for a function to have an inverse function, it must be one-to-one. Okay, so a one-to-one function means that for every y, there's exactly one x, which is the opposite of a function being a function. But it passes what's called the horizontal line test. So here's the key points here, because this is a little confusing to people. You can create an inverse for anything, but it doesn't mean that it's going to be a function. Because remember, to be a function, it must pass the vertical line test. It must. So this is my horizontal line I'm going to test this with. And as you can see, this parabola does not pass the horizontal line test. So it is not considered one-to-one. Okay? The reason we test for that is if it's not one-to-one, the inverse of it is not a function. So look at the inverse over here. The inverse on the right is not a function because it doesn't pass the vertical line test. So when we flip something over the y-axis, the y equals x, if we flip it over the y equals x line, then the x's and y's are going to switch. So stop for just a moment and think about this. If it doesn't pass a horizontal line test and you flip it over the y equals x line, it is not going to pass the vertical line test over here. Okay, so that is why it has to be one-to-one in order to have an inverse that is a function. Okay, so pause it there. Think about what I just said. Rewind if you need to, and then we'll move on. Okay, now it is your turn. I want you to show that the function 4x minus 6 is one-to-one. And what I want you to do here is I want you to graph this. And then I want you to explain in the Edpuzzle why you believe it is one-to-one. What about this graph or what about this function are you able to say it's one-to-one given the definition that I just gave you? Okay, so all I really wanted to hear you say here was that when you graph this and you check it with a horizontal line, it does pass. Oh, it's not going to let me do it over on top of it. If I went up and down with this line, you would see that it passes the horizontal line test. So that horizontal line is only going to cross through one thing at a time. It's never going to cross through 2 points. So when you take the inverse of this, it will be a function. So it does pass the one-to-one horizontal line test. Okay, the next thing I want to talk about is restricting the domain to find the inverse of a function. So why would we restrict the domain? Well, if you look at the x squared graph, you find that it's got an inverse if you restrict it. So if it went on like this, it would not pass the vertical line test. The horizontal line test. This is not a one-to-one function. But if you restrict it and you don't include this part over here, take that all away, by just simply saying that x must be greater than or equal to 0. So that means now it only goes from 0 up. So now this function is going to pass the vertical line test because when we flip it over, because it passes the horizontal line test. It is one-to-one now. So first we have to show that it has an inverse. So we're going to find the inverse of this function. So we've got g of x equals x squared. And so we're going to place the g of x with a y, and we're going to switch, and then we're going to solve for y, and we get y equals, I'm just switching sides here, the square root of x. Okay, and what that graph looks like is exactly like what we were looking for, which is it looks like that. I don't want to cover up what I'm doing here, but no, let's move it on up here. Okay, now the question is, does that pass the vertical line test? Is our inverse a function? It is. It is a function. Whereas if we had not limited the domain like we did before, if we had not limited the domain to x is greater than or equal to 0 here, right there, we would not have a function here because the whole thing would have flipped over and it would not have passed the vertical line test. Okay, so as it is though, what we did was we limited it and we made it so it does have an inverse. Okay. Okay, the last example I have for you is that we are going to find the inverse of this and graph both g of x and its inverse on the same set of axes. So the first thing we have to do here is we replace g of x with a y, and we say y equals x plus 2 squared. Now notice this is limited, so when we go to graph it, we have to limit it. I'll continue on with this. Okay, now we're going to switch the x and the y. Okay, so now we have to solve for y, which is a little more complicated than what we've done in the past. So I'm going to take the square root of both sides to get rid of the square there. And I get square root of x equals y plus 2. So now I'm going to switch sides here for everything. I'm going to take y and I'm going to say equals, if I subtracted 2 from both sides, I'd get square root of x minus 2. Okay? So square root of x minus 2. And I want to make sure that we're clear on the fact that the square root is only the x. Only the x right here. Okay, so now we want to graph both on the same set of axes. So let's look at that on our graph. So first we have y equals x plus 2 squared. So you may recognize that this is a parabola here that's been shifted to the left. It's just the x squared graph shifted to the left. So again, transformations. Then we're going to look at the inverse, which is that one. Okay. So if we took a horizontal line and we tested the original, the purple one, it would pass the one-to-one test. And if we took a vertical line and we tested the inverse, it would pass the vertical line test. So that's our function that's been limited to -2 or greater, and our inverse. Okay, this is our last check it out. I would like you to try this one. Show that the function f of x equals x to the fourth, where x is greater than or equal to 0, has an inverse, and find the inverse. So in the Edpuzzle, I want you to explain to me what you see on your graph in words, and tell me why it has an inverse. And then find the inverse and report that in the Edpuzzle as well. So the way that you're going to show that y equals x to the fourth has an inverse is by doing the horizontal line test. And if you graph it, you can see that it is 1-to-1. It passes the horizontal line test, so it will have an inverse. And so then you find the inverse by switching the x and the y, and you get the inverse function of x is the fourth root of x. So hopefully you're able to do that in Desmos. And we haven't talked about this, but in order to find any root but 2, you can write nth root, and it'll pop up with a little place for you to put in the root symbol here. Okay. So in Desmos, you want to say nth root, and it'll pop up with that, and you can enter the number that you want there. All right, and so last thing, I want to show you the graph of this. So the fourth root of x is the inverse of x to the fourth. All right, thanks for watching.